By now, you should understand different maintenance programs. Our topic today is quality auditing, whereby we make use of the existing CBM program and make additional proactive steps ahead for the maintenance of the machine's condition or health. In CBM, many times we only look for those primary machinery faults, which are imbalance and misalignment. These two faults basically takes up to 70% of the overall machinery faults. Sometimes, the faults will be associated to other possible secondary causes like faults at bearings, gears, belts, electrical motors, or even machine's mechanical looseness. All the faults mentioned in previous slides like imbalance, misalignment, looseness, etc. are caused by degenerations of the machines itself due to long operations and inefficient maintenance. They could be detected and rectified by implementing vibration monitoring in the maintenance programs. Either it is preventive or predictive maintenance. But how if the system from birth already carries with an inherent design faults? Individual machines components are generally dynamically well designed and rigorously tested. Here, dynamically well designed is referred to the design of the machine's components is free of high vibration issues due to low resistance at its operating conditions, in which we have discussed in our previous topic. In short, no resonance related issue happen in this case. Take a motor coupled pump machines as an example. Motor and pump manufacturer, when they design their motor and pump, they will perform number of tests and simulations to ensure their design have no issues of high vibrations due to resonance. However, when these machines are assembled together, there is a possibility of change in dynamic characteristics cause the unexpected behavior of the system. The most common change is the shift of natural frequencies. It means if no extensive study of the dynamics of the new machine's assembly, there is a possibility of getting into resonance issues at the machine assembly's operating conditions. Usually, the assembly will locally or internally design, fabricated, and installed. And many times, it was assumed that there is no dynamic design issue, but it happens that there were high vibration issue on this machine assembly since its first day of operations. Here, we say that procedures in CBM is generally assumes high vibration is caused by wear and tear during operations due to machines degenerations. However, a considerable percentage of machines have been installed and commissioned with inherent assembly design flaws. By eliminating the design flaws, if any, before it start operations, it could reduce the CBM task to merely trending and diagnosis of machines due to degenerations caused by the operation alone only. So, what is quality auditing? Basically, it carries the existing CBM scheme to another level up. Look at the bathtub profile. Without CBM, usually the maintenance cost and downtime cost is high during the assignment stage, relaxation stage, and anxiety stage. This is because the conditions of the machines cannot be predicted and involve higher costs when a sudden machine breakdown happens. Assignment stage is referred to after commissioning and getting the machines to start operations. No history and conditions of the machines means require higher maintenance costs. Meanwhile, relaxation stage is referred to operations started and usually no frequent breakdown as most of the parts are still new. Finally, anxiety stage is referred to when a sudden breakdown happens due to machine degenerations and no corrective measures available. With CVM, in practice, we can see that the maintenance or downtime cost is significantly reduced in all these three stages. By incorporating on-site quality auditing, here it is referred to Dynamic Design Verifications or DDV into the CBM scheme. The CBM scheme is further enhanced by eliminating the design flaws in machines at the onset of plant operations. It further reduces the maintenance and downtime costs as compared with the practicing CBM only. First, it reduces the teething periods and costs during assignment phase. By performing systematic design verification to all or major machines, rather than using a trial and errors methods on problematic machines. By getting the machine up and running using the trial and errors approach may temporarily hide the design flaws only, with the wound would be opening up at the later stage. Secondly, reducing downtime in the relaxation stage as replacement of parts are purely due to the effect of operations rather than the design. Machines monitoring would generate a more consistent and predictable trend patterns, as design flaws would generate a relatively more random behavior of measured parameters. Finally, it prolongs the lifespan during anxiety stage, as any wear and tear is caused by machine's operation alone, and it is not coupled with the design deficiencies. We always say that bearing may last longer than the machines if it operates under the prescribed conditions. So, this is a brief introduction of quality auditing. At the later stage of this course, we will discuss on the detail of DDV procedures. Basically, these DDV procedures involve several advanced vibration analysis techniques which are used to eliminate dynamic design issues of the machines.